Hey, hello everyone. Yep, so let me quickly do this quick test. You all able to hear me? Yes or no? Can you please confirm on whether you are able to hear me or not? Okay, wonderful. Industry oriented. Oops. I'm just trying to make it YouTube live. Just allow me a minute, faculty members, and we should get started. Just give me a minute. We are just figuring out on how to go YouTube live. Yep, I think we are YouTube live now, so we should continue. All right, let me click on the mind map here. Let me do a drop down and go to AI and deep learning. And friends, you all would have received AI Spry access. Okay, if you haven't received, that means you either did not register. Okay, that is the only reason that I can think about. But just a minute, sorry. Yep. So friends, quickly let me check with you all on did you all receive LMS access? Yes or a no? Please can you reply to this? Wonderful. Yeah. Okay. Wonderful. Okay. So roughly, so um, do one thing. I'll put it here. Oh, I'll not put it here. I'll put it in the chat. Send an email to Smita at the rate 360digitmg.com. And you know what? People who registered with us have we have given them LMS access. On the first day, we have asked everyone to register, and whoever has registered, we have given to them. Whoever has not registered, maybe you didn't attend the first day training, or maybe you didn't pay attention, whatever be the reason, you can drop an email to smita at 360digitmg.com, right? I've sent that email. Please drop an email on that. Okay, let's move on now. So AI and deep learning, we understood about CRISP-DM, which is cross-industry standard process for data mining, in which we understood about business problem. We know how to create the project charter. I mean, we didn't learn about that, but we create project charters as part of the live projects, data collection. Once you collect the data, you perform data cleansing or data preparation, exploratory data analysis, or feature engineering. Then we conduct data mining. We get into data mining machine learning, in which we already discussed about the first technique here, which is artificial neural network or multi-layered perceptron. Today we will discuss about CNN, but before that, we are supposed to complete the computer vision aspect. We discussed about how to represent an image as a function, basic transformations which can be performed. We discussed about filters, kernels, or masks, and we discussed until, sorry, edge detection. Right. And the last thing that we have discussed was about CANNY edge detector. Okay, we have covered the ground until here. Now let us understand about image sampling and interpolation. If you have an image and if you have to make that image half, if you want to reduce the size of the image into half, what would you do? Right? If I remove every alternate row and every alternate column, okay, if you remove every alternate row and every alternate column, what do you think will happen? Okay, what do you think will happen? The size of the image will become half. The image will become half if you throw away every alternate row and column. But then, say this is half the size. If you again throw away every alternate row and column, this image will become 1 by 4 the size. And if you throw away every alternate row and column in this, the image would become 1 by 8 the size. But then, when you zoom it back, there'll be a lot of craftiness in the image. Right? What do you mean by craft? A lot of distracted, clutter, in that way. How do I counter that? And what would happen if I do not counter? Okay, so let me get that directly. To counter that, what people do is whenever you downsample an image, they apply a Gaussian filter on that. So you downsample the image. Downsample means reduce the size of the image. Then you apply Gaussian filter on top of that. Filter or kernel or mask. When you apply the Gaussian filter and reduce the size of the image further, it will reduce further. Again, you apply the Gaussian filter, again reduce the size. And when you zoom it back, this is how it appears. If you do not apply a Gaussian filter, this is how it appears. Did not apply Gaussian filter. This is how it appears. If you apply Gaussian filter, this is how it appears. And if you're working with images, textual images, basically, for example, I was speaking about the doctor prescription form. And if that prescription form has to be converted, this data is in unstructured format. This unstructured data, if you want to convert it into a structured format, what do? You'll have to read each and every section, name of a person, gender of a person, so on and so forth, and you'll put it in a database. Name, gender, age, symptoms, prescription, so on and so forth. When you scan this, this will become an image which is unstructured, right? When you directly try to subsample the image, when you want to reduce the size of that, this is how it would be. Actually, nothing is visible. But then if you take this, if you apply a Gaussian filter and smoothen this is how it will become. After you smoothen the image, then you do a subsampling. If you do a subsampling, this is how it appears. Okay, next. If you have an image, okay, anti-aliasing, forget that. Now, so whenever you have an image, whenever you want to subsample it, first blur it. You blur it using Gaussian filter. Okay, and then you get the subsample. Again, what do? Again, you blur it using a Gaussian filter. Again, you subsample. Again, you blur using Gaussian filter. And eventually what happens is you will get pyramid of images. And that's called as Gaussian pyramid. Okay, this is called as Gaussian pyramid. So you have pyramid of images basically. A very small image, slightly bigger image, slightly bigger in this way. So how can I use this in practical? In practical settings, how do you use that? Say you have a Facebook image. And you, along with your friends, have taken a photo and then you uploaded this image on Facebook. And then I'm sure you are aware of Facebook auto tagging. Right? It will automatically tag the names of your friends when you upload the image onto Facebook. Okay. How does it do that? Say this guy is your friend by name Sharath, and this person is there in your friend list. So what Facebook does is it will take all the images of Sharath and say all the images of Sharath were close-up images. All the images were so large, but the photo that you uploaded has Sharath photo which is so small. It is this small. But ideally, his profile pics, Sharath's profile pics, are very large. So what do you do then? You have to actually take Sharath's profile picture and come up with a Gaussian pyramid, basically. When you come up with a Gaussian pyramid, somewhere the size will become smaller, smaller, and Sharath's picture will be so small. And this, when mapped with this image, it will make sense. Okay, and this is how it works basically. Gaussian pyramid, right? And take any example. For example, not this. If you take example of a satellite, basically, right? What happens is you keep reducing the size of the image, you blur it. That is, apply Gaussian. Applying a Gaussian filter will blur the image. Then subsample, then blur and subsample, blur, subsample, blur and subsample. Do that. Okay. And when you take the satellite imagery, this will be extremely helpful. Basically, you don't need a very big image. You need smaller and smaller images. And let me tell you one more thing. In the cancer image that we have dealt with, when we have pathology images, pathology images, sorry, are usually of 1.5 GB. Okay, 1.5 GB is a very large image. You cannot even open that on your typical computers. So what do? You have to apply all these things, downsampling things. Okay, so okay, that aside, we typically, you cannot open on your typical computers. We use software such as Leica, etc. That aside, but the idea is when you subsample, it would reduce the size of the image significantly. And then that smaller image can be used for your analysis. While on one side you have this downsampling, how do I upsample it on another side? Yesterday there were a few questions around that. Okay. If the image is too small in this way, how can we make it 10 times as big? How do you do that? So if you just keep adding the alternate rows and columns 10 different times, then obviously your image will become 10 times bigger. However, what kind of techniques are applied? That's one thing that you need to understand. Second thing is, what are the techniques which are going to be very effective? To understand that, let's only discuss about one interpolation technique, which is called as linear interpolation. Of course, there is bilinear interpolation, cubic interpolation, etc. But we will discuss about a couple of things. One is linear interpolation. What does that mean? Say you have an image like this. Okay, and in this particular image, um, say there is a pixel value. Okay, let me put it in this way. Say you have an image like this. You need to increase the size of the image. So you need to add more pixels, right? Say this pixel is here, this pixel is here, this pixel is here, and this pixel is here. That means when you want to increase that, you need to add these pixels. Let me choose a different color. Yeah, you have to add in these pixels. This, 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 and this. How do you do that? Let me take the first row alone. Okay, let us take the first row alone. So you need to fill this part. So what you do is you take this pixel, you take this pixel, and to get the central pixel, all you need to do is you'll say 1 minus a into this pixel intensity value plus a into this pixel intensity value. If you choose a as 0.5, then what happens is you're going to give equal importance to both the pixels. You're going to give equal importance to pixel on the left side and to the pixel on the right side. So it'll be 1 minus a into zero point 0.5 or 0.5 into function of this plus 0.5 into fn, right? That means you're giving equal importance and then you're solving it. This is how you fill the additional pixels so that your image becomes bigger. This is one thing. Another thing is you also have something called as bilinear interpolation. What happens in bilinear interpolation is that if you want a pixel value here, then you consider all the four corners. Okay, you consider all the four corners. And suppose this is I comma j, right? So it'll be something like 1 minus a into 1 minus b into f of ij plus a into 1 minus b into f of I plus j, this, plus a b into this value plus 1 minus a into b into that value. When you solve all those four, you get this. This is bilinear interpolation. In that way, you also have bicubic interpolation. This is one thing. Second thing is, we can also use SVD. Let me see if I can show you that. It is out of scope, but just because a few of you all have asked, let me show you that. Let me go here. Let me go to AI Spry and let me log in with the username and password. And then let me open the, where is that? Where did it go? Mm-mm. 1 second. 1 second, friends. Yep, here it is, study material. Okay. Let me go to dimension reduction. Should be there in SVD. Or I will show you right away. Just give me 1 minute. Um, mm, uh, or let me put this SVD and an image. Let's see if I can get to that exact folder and then show it to you guys. That would be there, and Just give me a minute. Sorry. I just want to pull out something very interesting. That's a very interesting stuff. But then if I don't show you that, okay, just looking on my mobile. Um, yeah, this one. Yeah. So here what happens is, say this is the image. You might be having an image of this quality, right? So in SVD, what you do is there is something called as a K value. You keep increasing it. Or you take the original image and you just keep increasing the something called as K value. Keep increasing that. Though the size of the image increases, the clarity improves beyond imagination. This is another way of getting a high resolution image from a low resolution image. And remember one thing, making it high resolution means nothing but you're adding more and more pixels. That's it to the image. You're adding more pixels. That's it, simply put. So you have your original image. You have your nearest neighbor interpolation, bilinear interpolation, and bicubic interpolation. Okay, you can try out any of those techniques. All right. Now back to our discussion. We need to complete the remaining code. And I'm also going to show you edge detection. Yesterday we discussed about a few edge detection techniques. I'm going to do that in Python using OpenCV. And today we will do something interesting. And that interesting thing would be, I'm going to open a webcam and I'm going to help you guys detect the face. Okay, we'll do that. I think I need to close this and relaunch it. Let me go here. Anaconda. It's taking a while. Okay. So here we have Spider. I'm launching that. Cancel it. Yep. Okay. OpenCV. Where are we? Yep. Here it is. Copy the entire thing and then paste here so that I might go to the appropriate section and show it to you guys on how to apply filter. It should be somewhere here. Yeah, found it. Okay, so here we have edge detection filter. Okay, I'm importing the required library here, which is CV2 and NumPy. Yesterday we discussed already that okay, that we can read the image using CV2, and here I'm giving the complete path of the image. Okay, and I'm taking an image which is called as median filter. Okay, and then we're doing CV2 dot image read, and we are reading the image in grayscale format. Okay, so let me load that. Since you're importing this image in a gray format, you do not have comma 3 here. It says 490 comma 536 comma nothing. Okay. When you say image.shape, and then you're storing that in rows and columns. So in rows, you have the number of rows. If you observe here, image.shape, when you do that, it will take this 490 and 536. 490 is stored in rows. 536 is stored in columns. So you have rows and columns. And then you're doing this. CV2.Sobel. You're applying a Sobel filter on the image. Okay. And this component that you're seeing here is used um, to calculate and find the depth of the image. Depth means how deep. So depth is another feature. And where is depth extensively used? Let me quickly tell you that as well. When you play games such as Kinect, Microsoft Kinect. Okay, let me go to images if I can find a relevant image. Usually, when you look at Microsoft Kinect, you'll have this depth sensor. Yeah, here it is. Okay, the depth sensor. What would that depth sensor capture? How far or how close you are to that Kinect. So is there any swinging, etc., that I can show you? Hmm. Yeah. So say here, for example, you're kicking the ball, right? How far are you or how close are you to this? And with what force are you hitting the ball? These kind of things also should be captured to give you a real game illusion, right? Or think about it as a golf club. You swing the golf club, and based on the speed at which you swing, your Microsoft Kinect will tell you how far the ball will reach. Say you're practicing cricket for that case. If you swing your bat very hard, it will show you on how far the ball is going, basically. Okay, so that's how it is basically. Now, those kind of things are captured using this depth cv2.cv underscore 64f. Then you have 1 comma 0, and you're putting the kernel size as 5. Now you would obviously have a question, hey, what is this 1 comma 0? So whenever you get these kind of functions, right, I can readily explain that, but let me also show you on how to do some research. These are all OpenCV related flags. Okay, these are called as flags within OpenCV. And cv2.sobel, where are you, my dear Sobel? Where is that? Here, maybe. Okay. Otherwise, I can explain. I mean, you can just go here and then do some analysis here, but that's okay. I will let you know on what these mean. So here, one means you want to find the Sobel along x-axis. 0 means you want to, I mean, Sobel along y. So you're saying, if you say 1, 0, that means you want to find the Sobel along x. And the kernel size here is 5. What does that mean? You'll have a 5 by 5 filter that you are going to apply. And it also says, I'm storing that in Sobel underscore horizontal. Horizontal edges, basically, right? And then you also have vertical edges. So 0 cv2.sobel on the image. The depth part is what you are mentioning here. And here you're saying 0 and 1. So the 0 and 1, 0 means this, y means along y-axis, 1 means along y-axis here. So 1 is active, so you want to find the edges along y-axis. Okay, and you want a kernel size to be 5. So it is 5 by 5 kernel size. All right. So when I run this, you get these values. This is the original. This is your Sobel along horizontal, and this is your Sobel along vertical. Look at what's happening here. So when you move in this direction on x-axis, from black to gray, when you move, you'll have an edge. Do you have an edge? Yep. Then it's all gray, 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 and then white, right? So that's how it is. So there is no change. When you move along in this direction, you'll have an edge there. Again, here from gray to black, you'll have an edge there. Then you move along completely, you'll have an edge there. And then you have an edge here. And if you find edge along this direction, you have an edge here, you have an edge here, right? In that way, edges are formed in horizontal and in vertical. This is vertical in this direction you're moving. So these are the edges that we can identify. Next, when you use something called as Laplacian, we are doing that on the same image. Nothing changes. The only thing is I'm going to, instead of applying Sobel along X and Sobel along Y, if you just apply Laplacian filter, let's see how it appears. Wow, wonderful. Laplacian is doing a much better job. You have your original image and Laplacian. Look at that, wonderful job. And one more thing is, as we have discussed yesterday, if you take a Gaussian filter, and if you find the first derivative of it, would appear like that. And if you find the second derivative of this, I mean, find the derivative of this yet again, then it will appear like this. Okay, and here when you look at it from the top, you will see as if there's a circular shape. So that's what is happening. So you have all these, you have those circular shapes. But then there are certain images on which it doesn't work well. Say you apply Laplacian on another image which is called as plane image. So let me show you this image first. Let me take this path and then Here we have a plane, right? Plane. Now, if you image read grayscale, when you do that, you'll have that plane, right? So you say cv2.image read. And on this image, if you apply Laplacian, what happens? Let's see. So here is your original image and here is your Laplacian. It's completely confused. And these are called as spurious edges. Too many edges, not needed. Too many edges are getting identified and actual image is not appearing properly, right? So what do we do then is we will resort to our, you know, algorithm that we discussed, and that is CANNY edge detector. Remember, in CANNY edge detector, you have to give your lower threshold and upper threshold. And these lower threshold and upper threshold values are values which are chosen by us, you or me, as AI experts would choose these lower threshold and upper threshold values. And now CV2, NumPy, image read, the same plane, right? Same grayscale. Then you're taking the shape of the image and putting that into rows and columns. Even if you don't do that, doesn't matter basically. And then you're doing cv2.canny. That would apply canny edge detection algorithm on the image. And you have lower threshold and higher upper threshold. And then you're saying, show me the image, this canny, in a window and name the name of the window as canny. And then you have the wait key. First of all, I need to select this and press escape. Only when you get this, you can be rest assured that, okay, the previous function is done. Close. Let me close this also. Now, if I were to run this, wow, amazing, isn't it? So all those spurious edges are gone. It is actually identifying the edges of the image correctly, properly. Okay, so that's how it works. Then what I want to show you now is something which is very, very interesting. But then I will first explain the code. I will not run it. I will explain the code. And once we take the break and come back, I'm going to run it. So what am I going to explain? I'm just ignoring a few of the code which is not important. I am going to show you now on how to capture the video, live video stream, and how do you detect human face? How do you detect the eye of a person? Okay, these kind of things is what we are going to understand now. So let me help you understand. So here there is this function called cv2.video capture. This is used to capture the video. Once you are going to create an object, okay, once it's created, we start an infinite loop and we keep reading the frames of images continuously until unless you stop it, it will continue to capture the frames of webcam. So what you're going to do here is you're doing this wherein capture, if not captured, is open. I mean, if your camera is not open, then raise an input output error which says cannot open webcam. You need to know, right? If something is not working, you need to be notified that something isn't working. Okay. And if you say while true, whenever you capture, so here, do you know what? Another function here is until and unless you press the escape key. Remember, I was telling that escape key has an ASCII character of 27. If you press escape, only then it will break. Until then, your video will be continuously recorded. Okay, continuously it is recorded. And what is the 00 is for the default uh, webcam that you have. Okay. And what are we doing here? Basically, uh, we are saying return a Boolean value. Boolean means true or false. True means a frame has been read. False means frame isn't captured. Okay. This return here only says on whether your frame has been correctly captured or not. If the frame is correctly captured, it is stored in this object called as frame. Remember, video is nothing but collection of multiple frames of images. Video is collection of multiple frames of images, and you're opening your webcam, and then you're saying if the webcam doesn't open, throw an error. If the webcam opens properly, then return true or false, and also capture the frames. If the frame is correctly captured, it is stored in this frame, otherwise not. Once you capture the frame, what you're doing is you're resizing the frame. How are you resizing? You're just, I mean, here, when you say none, right? Ideally, you're not doing anything. That's what it means. Ideally, you're not resizing in any way. But then what you're at least trying to do is you're trying to ensure that you you locate the central point on x-axis and y-axis. So that will be the central point of your image. Okay. If at all your image is smaller than your window size, if the webcam is capturing only so much out of the window size, what will happen? All these borders this entire border, there you'll do an interpolation. And then you want to show the image. You want to give the name of this window as input. And within that, you want to show the frame. Interpolation is nothing but, it will just expand your image like this. If you expand the image, what happens? This size of image will become this size. Then how are you going to fill the missing pixels? Using interpolation. There is something called as area interpolation. Like we have seen linear interpolation, bilinear and bicubic, or cubic, bicubic, etc. In that we have something called as area interpolation. And you're here saying that cv2.wait key of 1, meaning you wait for 1 millisecond. That's it. After 1 millisecond, if you press escape key on your keyboard, done. After that, you have to release your webcam for some other purpose, right? Otherwise, what will happen? It will keep capturing and keep consuming your memory. And then you're saying destroy all windows. That means completely close the entire process and then move on to the next process. I'm just going to run it. And very good. So what I should do is, what happens is this webinar jam actually captures and keeps track of the webcam basically. So I just removed it and then connected it back. Let's see what happens now. Yep, now it should work. That's the webcam. I'm not showing anything now because after the break, I'm going to show you, okay, on how to capture the image of a person. Live stream. Live stream, we will capture the image, and once we capture the image, we will detect the human face. Okay, we will detect our eye of a person, etc. And how are we going to do that? What algorithm would you use? Okay. The algorithm that I am going to use, or we are going to use rather, is called as cascade. It's a collection of multiple machine learning algorithms. Basically, it's a cascade of multiple machine learning algorithms. And way back in 2001, people by name Paul Viola and Michael Jones, it's called as Viola Jones technique, it paved the way for the field of machine learning in itself. That's an awesome paper. I mean, you have to read it when you find time. Viola Jones thing, right? It's very, very effective. So here what happens is, if you are displaying a video, in that video, you would put a rectangle. Let me call it as A, B, C, D. You'll put a rectangle inside that particular video, and you'll capture the area of the rectangle. And to capture the area of the rectangle, you use AC minus AC. Oh, sorry, AC should be diagonal. Let me put it this way. A, B, C, D. So diagonal. AC minus AB plus AD minus AA. When you do this, basically, you'll be able to capture the area of this rectangle. But why do we care about this? So Haar cascade says that if this is the size of the rectangle, take that size and apply on entire portion, like a filter mask, entire. I mean, it would be very overwhelming basically. And not just that, it is also expected that you don't just use this size rectangular image, you also keep reducing. If you do not find an image, for example, say you have a human face here. Say you have a human face here. And in this size rectangle, say you could not find the human. Then what is the next step? The next step is to increase the size of the image. Okay, so what happens is, say you're using this size window. You have taken that size window and then you traversed it completely, but it could not detect the human face. So next what happens is, you'll have argument. I'll show you that argument also. There will be an argument that you have to give which says that if you do not find an image in this size window, rectangular window, when you move it across this video, if you cannot find the human face, increase this by a certain factor. That's called a scaling factor. If you say 0.5, that means you're going to increase this by 50%. So this window size will become like this, 50%. And you take this and then traverse it. And with that size, if you can find the image, your algorithm stops and says that, okay, I found this particular image. But there are a lot of computations which are needed. And the overall process is very small. And in real time, if you say that, okay, I'll create window size, I will traverse it, find a human. If I cannot find it, I'll increase the window size by a scaling factor. And then again, I will apply it. That would be very cumbersome. Okay, so that is why we have this area of rectangle, because if you find this an area of rectangle, all you need to know is these 4 points, A, B, C, D. All you need to know is not all those things, but only these 4 points. So it'll be faster when it comes to computation. Rather than looking at each pixel inside, you're just looking at these four. Right? That's the reason why it is much faster. Okay. Now let me quickly look at your questions. All right. Yeah, sure. So, when did you send LMS credentials? We sent it, I mean, 2 days back, Prasad. If you haven't received that, you can drop an email to, okay, once again, I'm mentioning this. If any one of you haven't received LMS access, you might want to drop an email on that and you'll be given 3 months access. Don't worry. From the date that you get, 3 months. Post the link for material access like PPT and textbook. Ramon, we are not textbook driven, unfortunately, but certainly these training slides would be there on your learning management system. The code that we are showing and the images would also be there, Ramon. So you can make use of that. Yeah, increase, right, Asha Jyoti? Wasn't it visible? Okay, that's one thing. Specify the name of the paper once again. Okay, it's Viola Jones. Um, if I were to remember exactly, you can just type Viola Jones, CS UBC. Yeah, this one. You can refer to this. Viola Jones face detector. One of the most widely referred to paper. This is just slides, I think, but you'll also find some paper there. You can, yeah, paper is here, I think, if I'm not mistaken. It's based on boosted cascade. Boosted cascade means it combines multiple simple algorithms. Yeah, PPTs will be there in LMS only. Yeah, I shared that. So you can make use of that. No worries. Please drop an email and you'll be given access. Okay. Next question is rapid object detection using a boost. Yes, Ramchandran. You can also refer to that. Ramachandra also has shared one. Yeah. Saida, you can just drop an email to Smita at 360 and you should be able to get access. No, don't give your email ID. That won't help. Please drop an email to Smita at 360digitmg.com. Okay. And let me also quickly, before taking a break, explain you on how AI Spry would look like. Your AI Spry access would look like this. Let me see if something is already created for task. It will make my life easier. 1 second, 1 second. Okay. Say AI, right? For instance, yeah, it'll be like this. Let me open any of the AI. That'd be better. So you'll have the slides like this, friends. There will be additional slides also. Okay, there'll be additional slides also which will be available, and if you want to read those additional slides, please feel free to read. Again, as I've told you, I did not ask our team to only restrict to those topics that I discussed. I told give entire access. Though we are training for only 20 hours out of 80 hours actual training that we have, I asked our team to give complete access, and you'll have the data sets also. For example, if it is RNN, it'll be like this. Okay, and then you can click on next, next in that way and read that. And you will also be given access to the Python codes and the data sets. You can make best use of that. Okay, that's how it'll be. People who haven't received access, yeah, that's what I'm saying. Please, people who did not receive access, send email to this. Send email to that email ID and then you'll get access, do not worry. Okay, now let us quickly take a break, and then post break we'll do an amazing thing of facial recognition system. Okay, and we'll detect the parts of the human body. So please come back by 6:10, and until then we will have break. Post break, I'll take your questions, friends. Please take a break and come back. Now, are you guys able to hear me? Let me put a question here, poll question. Are you able to hear me now? Yes or a no? Let me see. Wow, wonderful. So all these files, so that's the reason. Okay, now I get it. I was all this while just putting a message here saying that if you did not receive LMS access, then please drop an email to smita@360digitmg.com. Is this part clear? If this is clear, we'll proceed further. That's what I was wondering. I was typing this and showing you, and then despite that, I was receiving certain messages. So it was a touch confusing for me as well. Anyways, now that you're able to see, let's proceed further. Okay. Okay. I am going to now enable the webcam. Oops. Very good. Now it should work. Are you all able to see me? This is a face behind the training, basically. I'm sure you were able to see me. Now, I am going to do something interesting. What I shall now do is I have enabled the webcam, and yeah, if I press G, it would convert the image into a grayscale video rather. And if I press Y, it has taken this image into a YUV color space. And if I press H, it is going to convert my image into HSV format. These are the various formats in which you can, enable the image. Again, gray, Y for YUV format, H for HSV format. Uh, yeah, now, yeah, you can use it on Raspberry Pi also. Next thing is, I would like to show you HA Cascade. HA Cascade, just now I explained, right, before the break, that it will identify your piece. Where did it go? Yeah. It will put a bounding box around the face, and it's going to track me. Uh, Whenever you find time, you can walk to our Madhapur office, High Tech City, and you can find our facial recognition system that we have built. We also deployed it at Coca-Cola and at a few other places. And one last thing that I'm going to do is I'm going to put a face mask. Will it work? Sure, it should. If it doesn't work, let's see. So what happens is, do you see that face mask? Augmented reality. Augmented reality means putting uh, putting an image on top of another image or a video for that case. It's kind of a mustache and all that, yeah. Anyways, that's one another application of computer vision. Then you have eye detection. Basically, what it does is it will first detect your face and then detect your eye. Why did it go there? So it will first detect your face, and you know that eye is something which is there inside your face, so it's going to recognize those. Let me see if it works well here. Still it's able to identify, detect. Yeah, so you can do many things, friends, with this. Okay, I'm restarting the kernel because sometimes it doesn't work well. That's okay. Oops. Just give me a minute while I switch back onto my computer table. Okay. There was a request from one of our friend to explain about convolution part here, but then I'm a little scared that it will take some time. But then if time permits, I'm certainly going to explain that. Okay. Yeah. Good part is once again, if you did not receive LMS access, then please drop an email to smita at 360digitmg.com. Uh, it would be better. Okay. That would be better to track. Joydev, it works on Raspberry Pi also. That's why I'm saying you have to visit our office. You'll love it. You'll look into Raspberry Pi, how we have installed, so on and so forth. Okay. Now again, did you lose my voice? Let me put the same question again. Reset the poll. Yeah, for one time again, can you please respond? Yeah, wonderful. You're able to hear me, so no problem. So let me proceed further. Okay, next. We are now going to switch gears to convolution neural network, and we're going to discuss about CNN. CNN. Hmm. It's very surprising, 1 second. Let me see if I put it somewhere. If yes, where? Yeah, I found it. Oops. Just give me a minute. I would be surprised if I cannot find CNN. Mm-hmm. Oh, come on. This is very surprising for me. But anyways, I always have my plan in place. So I'll go to Computer vision primer. God, one second. Yeah, convolution neural network is here. Okay, so let us understand about CNN, convolution neural network, and how is it going to help us. Now you'll understand everything very, very easily, this neural network application, when it comes to images, became very famous in the year 2012 when people started working on this competition called as ImageNet competition. What happened in this ImageNet competition was that this ImageNet competition contains 22,000 categories. Okay, and it contains 14 million images. If you have 22,000 categories and 14 million images, um, I mean, this is the original data set, but for the competition, which was called as ImageNet competition, people were given 1,000 classes to deal with and 1.4 million images. 1.4 million images and 1,000 categories. That means if an image is given, we were supposed to classify on what that image was. And what happened in the year 2012 was amazing. A guy by name Alex Krzyzewski and his team, for the first time ever, they have used neural network on images. And the results were mind-boggling. And the error rate reduced by over 15%. Entire world was kind of shocked. What has happened? Amazing accuracy. And since then on, all the competitions which were won thanks to convolution neural networks. All people have done is they've tried out various, neurons, various layers, so on and so forth. And yep, you have a lot of things that you can address, such as image detection problem, image segmentation problem. If there is someone going on the road, would that person accidentally come in front of the vehicle? Can I predict that? Yes. Determining the alphabets, which are very tricky. Determining the basically number plates. Determining the pose of people. All these can be captured. Okay. All these basically are all image related issues. Determining how many veils we have, right? Overlaying map on top of the satellite image. All these are classic examples of how CNN can be used. CNN can also be used for image captioning. That means if you have an image, you can give name to that image. For example, a person riding a motorcycle on a dirt road, two dogs playing in the grass. All these are examples of image captioning. And why can't I use a typical multi-layered perceptron? Might be your question. Why do I need a different architecture altogether? Do you know what? There is another dataset called as Cipher 10, which has 10 different categories. And the images within Cipher 10 dataset are of the size 32 by 32 by 3, 32 wide, 32 high, and 3 color channels. When you multiply those three, you get 3072 weights. 3072 weights. And then if you take an image which is 200 by 200 size, the number of weights, if it's a color image, the number of weights that your model has to learn will just get exploded. And one more important thing is, say you have an image. What do you do? Say there is a human face here. If you split your image into multiple pixels, Okay, if you split your image into multiple pixels, and if you consider each and every pixel, in order to determine the image of the person, only this part is sufficient. Only this part is good enough. You need not have all these pixels. But what happens when you use a multi-layered perceptron is that if it's say 32 by 32, so you have all the 32 by 32 pixels or neurons, those many neurons. And to whichever layer you connect to another layer which has 100, for example. So it'll be 32 by 32 by 100. Those many weights your model has to learn. And you know what? 32 by 32 is a very tiny image, tiniest of the images. Typically, you deal with 1 megapixel. That is 10 raised to the power 6 into 10 raised to the power 6. Just imagine how many weights your model has to learn. That would be simply very overwhelming. Number one, weights. Number two, you're considering each and every pixel, which is actually not of good use. All these pixels are not relevant. They're not needed. All these pixels are not needed. Only these pixels are needed. These pixels which are inside are needed. Okay, so why are we wasting other resources basically? So with these 2 points, people have come up with, people thought, okay, using each and every pixel is irrelevant. And also the number of weights are simply getting exploded. How do we actually fix it? To fix it, people came up with another technique, which is called as convolution, which is a mathematical operation like addition, subtraction, deletion. You have something else which is called as convolution. Say this is an image, 5 by 5 image, and you have a filter or a mask or a kernel which is of size 3 by 3. So you have a 3 by 3 image. The values within this filter are nothing but weights of your network. If you have your input layer and if you have your convolution layer, you'll have all these connected to everything. So then all these will have weights. Those are the weights that you'll have here inside. Okay. So you'll have 1, 0, 1, 0, 1, 0, 1, 0, 1. Those are things which you see in red. Those are the filter values. If I take this filter and apply on this patch of the image, what would happen? 1 into 1 plus 0 into 1 plus 1 into 1 plus 0 into this plus 1 into 1, so on and so forth. Uh, when you do a sum product of all these values, you actually get the central value, which is nothing but 4. And then when you move this filter by one stride, you move in this way. One stride. Then when you again apply these 1 into 1 plus 0 into this, so on and so forth, you get this central pixel, which is this. Again, you move it by one stride in this way. So the weights will remain the same. The values within the filter will remain the same when you apply it throughout this image. And then you get the central pixel. Then you move here. Then when you apply this on this, you get the central pixel. And you'll get all those pixel values basically. Right? So all those pixel values will be populated. Now, the best part is when you look at MLP, if you have a 5 by 5 and if you're applying a 3 by 3 filter on that, what happens? 5 by 5 is 25. So you'll have 25 neurons. And 3 by 3 is 9. And you connect every neuron to every other neuron. Every neuron to every other neuron. So when you take a typical multi-layered perceptron, what happens is you will have 25 into 9, or in for that case you'll also have one bias. So 25 plus 1 into 9. Okay, 25 plus 1 would be 25 neurons plus 1 is bias into 9. These many weights your model has to learn typically. But when you come and look at your convolution neural network, what happens is, say you have your 25 neurons. I mean, of course, 5 by 5, that's the input image. And 3 by 3 is your filter size, which is 9. Now what happens is, you take, when you apply this patch here, you are applying on the first row, first 3 entries, right? So 1, 2, and 3. Then this and this are skipped. So you skip those two. Then you go to the next row wherein you apply it on the first 3. 1, 2, 3. Then what's happening? You're skipping these two, and then you're going to the third row. You apply on these 3. 2, 1, 2 are skipped. So 1, 2, and 3. So these are the weights that you have. What are those weights? 1, 0, 1, 0, 1, 0, 1, 0, 1. Okay. Now what happens is, if you assume that this patch is applied here on this portion, when you apply it on this patch, what happens is, you take these 3 values, and these 3 values will be the same as in this patch. When you applied it on this patch, these 3 are overlapping with this. So this 3 will remain as is. But then these 3 are used to come up with what? With this pixel value. So the central pixel, which is this. So what you're doing is the same weights are being used to get this value. So same weights are being used. You're not changing anything. Then you go to the next row. You apply it here by skipping this 2. And then the next 3, which will be 1, 2, and 3. Okay. So the weights that you have here and the weights that you have here are the same. Okay, the weights are not changing. So overall, when you look at it, and plus 1 bias would be there, of course, throughout. So overall 9 plus 1, 10 weights, that's it. Have to be learnt. Here, 25 plus 1 into 9, too many weights when it comes to MLP. But when it comes to CNN, the weights are shared. Weights are shared. That's a beauty. And how are weights updated? Initially, weights are, again, same logic. Initially, weights are randomly assigned. Then you move forward, calculate the error, and then go back and update your weights. Simple. Finally, once you are done with your algorithm, once you find the right set of weights, those right set of weights will be the same throughout. It won't change. A few more things that we need to understand before we get into the practical part of it. If this is your image, if it's 32 by 32 by 3, this 3 is also called as depth. It's one of the channels. It's also called as depth. And when you apply a filter, usually what happens is, even if you say 5 by 5, when you apply this 5 by 5 on this image, it will consume the complete depth. It will consume the complete depth. That means it will be 5 by 5 by 3. It will become 5 by 5 by 3. It will extend the full depth of the input volume. Next, each time you apply one filter, you're taking an image 32 by 32 by 3 color image, and you're applying a 5 by 5 by 3 filter. By 3, even if you don't give, it will assume the entire depth. It will consume the entire depth. Okay. So if you're applying that filter on the image, your filter will learn certain features of your image. Those features, like it will learn maybe the pixel intensity values or the edges or the blobs, etc. It will learn some features from your image. Those features are called as activation map or feature map. Okay, activation map or feature map. And here you have the feature map or activation map. This one, 28 by 28 by 1. It won't be by 3. Okay, just because you're using that, it won't be by 3, it will be by 1. Next, if you apply another 5 by 5 by 3 filter, you'd get another activation map or a feature map. If you apply another 5 by 5 by 3, you'll get another activation map. And if you're, say, applying 6 5 by 5 filters, 6 filters, you'd get 6 separate activation maps, and each of these activation maps will capture some feature from the image. And we have looked at a few features, right? That is intensity values, edges of image. All these are features in an image. You'll have texture, you'll have blobs, you'll have motif. There are many other features, right? Interest points and all that. Those kind of features are extracted. Next, if you have a 32 by 32 by 3, and if you're applying a 5 by 5 3 a 5 by 5 by 3 filter, even if you don't give 3, as I've told you, it will assume the entire depth. Okay. And if you're applying 6 such features, how many will you get in the output? You'll get 6 activation maps are combined together. But why is the size 28 by 28? Let me tell you. I'll take this example of 1 2 3 4 5. 1 2 3 4 5. And if you're using 3 by 3 filter on that, if you apply a 3 by 3 filter, and then it will calculate this central pixel. So you get the central pixel. This part. Then if you move it by one stride on this side, and when you apply it, you get the central pixel. When you move it by one stride here, you will get the central one. That's here. In that way, right? For all the pixels. But then what happened here? You cannot apply. You cannot take that and apply it here. Why can't you apply? Because these pixel values are not available, right? So you cannot calculate this portion. Hence it's not there. So if you have a 5 by 5 image, and if you're applying a 3 by 3 filter on that, ultimately you get a 3 by 3 image. In that way, when you apply it on 32 by 32 image, a filter size of 5 by 5, you'll ultimately get 28 by 28 image, because the border pixels on that you cannot apply. Then if you have a 28 by 28 by 6, and if you're applying 5 by 5, you need not give the 6, right? When you're applying 5 by 5 filter, it will assume the entire depth. And how many are applying? 10. So you'll have next depth as 10 in that way. What is this conv-relu, conv-relu? The filters that you're using in this convolution neural network are called as conv layer, conv filters. And then you're using ReLU activation function. We learned this at depth. So in a typical convnet convolutional neural network, you'll have convolution layer, ReLU, conv, ReLU, pooling layer. Conv, ReLU, conv, ReLU, pool, conv, ReLU, conv, ReLU, pool. This is the typical sequence in which you give, and it works wonderfully well. And then you're connecting it to a fully connected network. So you're taking your image, giving it to your network, passing it to the various layers, and finally you get the fully connected network. Now, a few things we need to understand. If I have a 7 by 7 image, and if you're applying a 3 by 3 filter, and if I say stride equal to 1, what would happen? It would move 1 pixel, 1 pixel, 1 pixel, 1 pixel, 1 pixel, 1 pixel. In that way, 1 pixel at a time it moves. If I say stride equal to 2, what would it do? It would skip 2 pixels. Here also it will skip 2 pixels. Here also when it comes down, it skips 2 pixels. It skips 2 pixels and 2 pixels. And then you again skip 2 pixels, 2 pixels and 2 pixels. Okay. Then if you say stride equal to 3, after this it has to move by 3 pixels and it will start throwing error because you're unable to consume this. It's left out kind of. Next 3 you cannot even apply. So it will start throwing error. It's not applicable. And if you have an n by n image, say you have a 32 by 32 image, and say you're applying an f by f filter or say 5 by 5 filter on the image, what will be the size of the output image is a question. For that, formula is simple. N minus f by stride plus 1. N is 32 minus filter size is 5 divided by, say you're moving the filter by 1 pixel at a time or 1 stride at a time. So by 1 plus 1. So it'll be, this will become 27. 27 plus 1 would become 28. So you'd get size of the image which would be of 28 by 28. Okay. Now, if you want the same size, for example, no, I don't want the size to be reduced. If I'm applying, if I'm taking a 32 by 32 and if I'm taking a 5 by 5 and if I'm convolving this on this image, then the end result should be, if you want the end result to be same 32 by 32, you don't want 28 by 28, then you have to do padding. Remember, this is also something that we have discussed, padding. This is a beauty, okay? If you understand computer vision, convolution neural network would become extremely easy. So you pad it basically. If you have a 32 by, okay, now let's take this example only. Say you have a 7 by 7 image. 1, 2, 3, 4, 5, 6, 7. So if you look at this, it's 7. and 1, 2, 3, 4, 5, 6, 7. If you look at this part, it's 7. So it's a 7 by 7. And then if you pad it with 1 pixel on the border, what happens is you add 1 pixel here, 1 pixel here. You add 1 pixel here and 1 pixel here. So that means you're adding 2 pixels. When you add 2 pixels, it becomes overall 9. And since you're adding 2 pixels, 7 plus 2 will be 9. So you have 9 by 9. On this 9 by 9, if you apply a 3 by 3 filter, now you'll get back the 7 by 7 image. Why? What is the formula? N minus F divided by stride plus 1. N is 7. So now it has become 9 basically because you have 0 padded across the border minus filter size is 3. Stride is 1 plus 1. So this becomes 6 by 1. 6. 6 plus 1 is 7. So you get a 7 by 7 image. So if your input size is 7 by 7, if you 0 pad it throughout and then apply the filter, you get back the original image. Okay, now next. Another very important thing that you need to remember. If you have 32 by 32 by 3 image, and if you're applying 5 by 5 filter, if you have 32 by 32, and if you're applying a 5 by 5 filter on this, with stride 1 and padding 2, then what happens? Padding 2 means you're going to add 2 pixels around the border. Okay, 2 pixels here, 2 pixels there, 2 pixels here and here. So overall what happens? You have 32 by 32. And if you're adding 2 here and 2 here, it becomes 36. And if you have 32 here, and if you're adding 2 and 2, it becomes 36. So if you have 36, which is n minus f filter size divided by stride plus 1, how would that be? 36 minus filter size is 5 divided by stride is 1 plus 1. So ultimately you get this is 31 plus 1 is 32. So you get 32 by 32. And how many do you have? 10. So 32 by 32 by 10 is what you get. Next, how many weights is your model going to learn? Remember, number of weights, even if you have 32 by 32 and 5 by 5 by 3, of course, because you have a color. So the number of weights will remain the same. The weights that your model has to learn will remain the same. It has nothing to do with your striding or padding or input image, nothing. It will just look into this. So it'll be 5 into 5 into 3 plus 1, which will be bias. There'll be a bias, right? Plus 1. So when you solve it, you get 76 parameters. But then you're looking into 10 such filters. For one 5 by 5, you'll get 5 by 5 by 3 plus 1 bias would be there. And total 76 parameters, but you have 10 such things. So you get 760 weights. There's a formula. I'll just skip that. Yeah. So conv relu pool. You understand conv relu is the activation function. But what is this pooling layer? Let us also demystify that before we break for the day. We already discussed about downsampling, right? What do you mean by downsampling? You have the image size. You blur the image using Gaussian and you downsample. You blur the image using Gaussian filter and downsample, right? On similar lines, for downsampling with a neural network, there is something called as pooling layer. So say this is the size of your image and you're applying a 2 by 2 filter, max pool with 2 by 2, straight 2. 2 by 2 means what? You apply on this patch. It's a max pool. So what happens is you take the maximum value, which happens to be 6, put it there. Take this, take the maximum value and put it here. Go here, stride 2, right? You're moving by stride 2, means 2 pixels. You take all these values, take the maximum value, apply it here, right? And take the maximum value. That's your max pool. You also have average pool, L2 pool, etc. Average means take average of all these 4 numbers, put it here. Take average of all these 4 numbers, put it here in that way. L2 means you square and add. You square 1 square plus 1 square plus 5 square plus 6 square and take a square root of that. That's L2. I mean, the people use only max pool majorly. Okay, so this is also another thing that will make our understanding clear. Okay, so that's pooling layer. So you have conv pool, conv pool, conv pool, and then you connect it to the fully connected network. Okay, tomorrow when we connect, we shall take this discussion further, and we are going to understand on how do we practically do it using Python. Okay, so let me quickly look at your questions. We will see that tomorrow, Rakesh Naik, practically when we do it. Theoretically, we are helping understand, right? So that's why we have taken in that way. You'll be given username and password, Kranti Kumar. Is there any we get meaningful border pixels? Didn't quite get that question. Yeah. No, immediately you'll not receive. It will take time. You send an email, you'll receive it. It will take time, but you'll receive it. A lot of you all haven't registered, right? So whoever has registered, we have given. People who haven't registered on the first day, maybe you didn't pay attention, whatever be it reason, or maybe we missed out, but we do not miss out usually because I'm personally following up with that. So you'll get it. Kranti Kumar, you'll get an email, and in that you'll have the details. Okay. All right, friends, then thank you so much. Attendance link is posted there. And I've already told you that you have to drop an email to a specific email ID and you'll be given access. We won't send any email like that. You have to send an email. Again, I repeat here, we will not be sending any email to you guys. You have to send us an email. Okay. Please send an email to smita at 360digitmg.com if you did not receive LMS access. Okay. Hope that answers your question. Smita at 360digitmg.com. We will check whether you actually registered or not, and then we will provide you access. Thank you all so much. We would again connect tomorrow and take this discussion forward. Thank you all, guys. Bye.